Picture this. It is a Friday night, and I decide, you know what? I am going to completely master the homemade French fry. So I do all the prep, I heat the oil up, and I end up pulling out this just absolutely sad, oil-logged potato sponge. I mean, have you ever faced that specific culinary defeat? Because it is rough. But today's deep dive actually gives me so much hope for our snacking future, because we are looking at research from Washington State University and the University of Illinois that uses the physics of dielectric heating to engineer a perfectly crispy, healthier fry.
Yeah, it is a really fascinating approach because the researchers, they didn't just treat this as a standard cooking challenge. They treated it as a complex physics problem involving heat and moisture and oil transport.
Which honestly brings up a huge misconception for me. I mean, I just always assumed that a French fry absorbs all that fat while it's actively sitting in the vat of oil. Is that not what is happening?
Not quite, no. So while it is submerged in the hot oil, the surface moisture of the potato is evaporating and actually pushing outward. And that outward pressure generally keeps the oil at bay.
Oh, so the oil can't get in because the steam is essentially pushing it away.
Exactly. The real issue actually happens the exact moment you take the fry out of the fryer. As the potato cools down, the steam condenses, and it creates a capillary vacuum effect.
Ah, so it acts like a sponge, pulling whatever oil is sitting on the surface deep inside the potato as it cools. Which definitely explains why standard fast food fries end up being, what, up to 20% oil by weight.
Right, precisely. So to combat that vacuum effect, the scientists turned to dielectric heating. Basically, when you expose food to an electromagnetic field, polar molecules, things like water, they are forced to rapidly rotate back and forth. They flip around, they collide, and they generate heat volumetrically.
Okay, so instead of cooking from the outside and like a normal convection oven would do, it is cooking the entire fry all at once.
Yes, and here is the really crucial key to all this. Water is highly polar, but fats and oils are not.
Oh, right, because they don't have that same molecular structure.
Exactly. So those electromagnetic waves rapidly heat the wet inside of the potato, but they practically ignore the oil and the dry outer crust.
Wait, hold on a second, though. Because if that is the case, why does microwaving a leftover fry turn it into a steaming, soggy mess?
Yeah.
I mean, how does hitting it with microwaves actually solve the oil problem if we know microwaves ruin fries?
Well, that is exactly where the engineering brilliance comes in. The researchers didn't just microwave it, they developed a hybrid system, so they actually fry the potato in hot oil while they are simultaneously hitting it with microwaves.
Whoa, frying and microwaving at the same time.
Yeah, and this cooks the inside so efficiently that it actually cuts the total frying time by 30 to 40%.
Which is incredible. But I imagine finding the exact right frequency and the precise timing for a complex system like that requires some really serious modeling and automation.
Oh,
Actually, speaking of training models and automating complex systems, that is exactly what our sponsor, Embersilk, helps businesses do. If you need help with AI training, automation, integration, software development, or if you are trying to uncover where AI agents could make the most impact for your business or even your personal life, you have to check out embersilk.com for all your AI needs. So back to the fries. They do this hybrid cooking process, but that doesn't solve the cooling vacuum problem, does it?
right, and that leads to what they call the post-fry. Once they perfected the hybrid cooking, they added this crucial final step. Right after the fry comes out of the hot oil, they blast it with microwaves for exactly 60 seconds.
Just 60 seconds. And what is actually happening during that minute? Because this part of the research completely blew my mind.
Well, remember, the microwaves target the water inside the potato, not the oil. So it rapidly heats that remaining trapped water, which creates intense internal vapor pressure.
And that vapor pressure essentially acts like a microscopic piston. It physically pushes outward, literally squeezing the excess oil right out of the potato's pores before that cooling vacuum effect even has a chance to suck it in.
It is so cool. It literally forces the oil out from the inside.
So for you listening right now, this 60-second trick reduces the total oil content by 18 to 23%. And it does that without losing any of that necessary golden crunch we all want.
Yes, and what is also really notable here is the specific frequency they used. They found that an industrial 5.85 gigahertz frequency actually yields even lower oil levels and better texture than the standard 2.45 gigahertz frequency that we all use in our home microwaves.
Oh, so this isn't just about redesigning a better home microwave for leftovers.
No, not at all. The implications for industrial food engineering are absolutely massive. By manipulating specific wave frequencies, we could completely revolutionize how packaged and fast foods are processed on a global scale.
I love that. It is just incredibly optimistic. I mean, we are literally using cutting-edge physics to engineer elegant solutions that let us enjoy the comfort foods we love, just in a much smarter, healthier way. Which leaves you with a really fun thought to chew on today. If we can mathematically model electromagnetic waves to hack the perfect French fry, what other notoriously unhealthy comfort foods are just waiting to be completely reinvented by food engineers?
I would bet there are whole new methods of processing hiding right around the corner for so many of our favorites.
Totally agree. Keep wondering, keep learning. And hey, if you enjoyed this podcast, please subscribe to the show. Leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.